Hi folks, we're in 52 weeks of Python. This is week number 30 and we are going to be doing a review. In this specific lesson, we are going to be reviewing the basics that we talked about. That would be lessons 1 through lesson 9. In it, we're going to talk about dictionaries and lists and functions and strings, printing stuff, f-strings. We're going to talk about comparing data. We're going to talk about nested data. We're going to talk about the difference between assignment and copy and deep copy. We're going to be talking about some of the good programming practices like using enums or constants rather than literals. We're going to be comparing lists versus dictionaries and talking about why you should do one versus the other. This is going to be about 45 or 50 minutes of quick review of everything. Consider this to be like a cheat sheet for everything that you've learned, and hopefully it will refresh things in your mind that you may have forgotten and help to solidify things that you did learn but maybe haven't committed permanently to your brain. So without further ado, let's get started with the review. So let's talk about lesson 1 and remind ourselves what we learned. Well, we created this thing called device, and with these curly braces, as you can see, this is a dictionary. Remember, a dictionary has a key on the left, it has values on the right, and these two are separated by a colon. And so we have a device with keys of name, vendor, model, OS, etc. So this is a creation of a simple dictionary. In this situation, it's representing a device. Now, what else did we learn? We learned about print statements. So print is pretty easy. You can print something by just having a string. That's what's in these quotes. You print something and it will print it out exactly. This is just the \n does a new line, so it's a special character. When you want to print more than one thing on the line, here I have a string of device colon, and then I print out the actual device. It's going to just print it out in not very pretty a manner, but it will do that. One thing that I think I probably mentioned, if you have a comma here, then it will insert a space in between the thing on the left and the next thing that follows it. Here I am dereferencing just one particular item within my dictionary. The key that I'm passing in is name, so it's actually going to be printing out this value that you see right here. How do I dereference or refer to a specific portion of a dictionary, a particular item? I pass in the key, and that's how I do it with these square brackets in this manner. We got introduced to pretty print. You have to import pretty print, but once you've done that, you can do pretty print and it will print out your data structure in a nice, easy to read manner. So we'll look at that when I run this. The last thing we looked at was a for loop. So let's look at this. This isn't even a simple for loop. It's a little bit more complicated because I'm iterating through what type of data structure. What type of data structure is this again? Yep, it's a dictionary. In order to iterate through the keys and values in a dictionary, then I need to use this built-in function on a dictionary object called items, and items will give me a key and a value. And the idea of an iteration, like via a for loop, is that I will go through here for every single item in the list. So I will do name, then vendor, then model, then OS, etc. A little thing while I'm printing it here, of course you're noticing that we indent. You're familiar with that from Python, that we use, that we identify code blocks and function definitions, etc. using indentation. You got to be careful to do it correctly. I've had some folks ask me questions about problems that they had in their code that was traceable to bad indentation. So you got to make sure you do it correctly. And so within this, I'm printing out the data for the key and the value. But what's this weird format? Well, this thing right here that's in front of the quotes identifies it as an F string. So as an F string, that means it will print whatever is in the string, but if it sees anything in curly brackets, hey, there's a bunch of stuff in curly brackets here, then it will use Python to figure out what is the actual data that it needs to print. So this one here on the right is pretty easy. It's just going to print the value, which will be When the key is name, it will be this SBX thing. If it's vendor, then the value will be Cisco. Over here, it's going to print the key, but wait a minute. What's this colon followed by greater than 16S? Well, that is special formatting directive. So when I printed out value, I just said, just print it out however you want to print it out. When I specified key, I said, oh, by the way, I want you to do something special. I want you to right format it. That's the greater than sign. And I want you to have it take up 16 characters, and it's a string. So that's what the 16S means. If I run this, this is going to pop up here, and we can see the data that got printed out. So my first print statement, simple print, it printed the device. And like I said, it just printed it out right there. Not too easy to read. Here's a specific portion that we printed out. What does pretty print look like? Well, you know, that makes it way more easy to read. It's not super duper formatted, but it is easier to read. And lastly, with my for loop, this is probably, at least in my mind, a little bit more elegant way to print everything out. The left hand thing, which is the key, is going to be right justified because I did this special formatting, and the other string, the value, is going to be left justified, and that's what you end up over there. So that's what we learned in lesson number 1. So let's look at lesson number 2. I called it devices. Why did I call it devices? Because instead of doing just one device, we did a number of devices, and we used the Python list data structure. So I went through and I said, okay, for a particular range, so I'm going to go actually loop from 1 to 10. And then what I did was for every device, just like before, a device is going to be a dictionary. I'm going to have name, vendor, OS, IP address. These are the things that I'm going to set, and I'm doing it randomly, so you don't have to worry too much about this, but I'm basically using this choice functionality that I had to import from random, and I'm choosing that my device vendor is going to be Cisco, Juniper, Arista. My OS is going to be one of the appropriate OSs, etc. We don't have to worry too much about that. What I did then was I did another one of my little for loops where I printed out all the information about that device. But hey, guess what? I have a for loop that's inside a for loop now, so that's going to happen multiple times. And then with a list, what you do is you add things to a list by doing an append that puts it at the end of the list. So at the end of this loop here that we see, this for loop, at the end of this, what I end up having is a list of devices. From that point, I do a pretty print of all of the devices. And then, just for kicks, I actually use something that we found out that we needed to actually install, this thing called tabulate. It doesn't come for free. There's some functionality that was contributed that is available to be installed via pip. And so we did that, and we're using tabulate, and what that is going to do is it's going to print everything out in a nice table. Not only that, but look at this. I'm calling tabulate on my data, but before I do that, I'm calling sorted on my data. So I'm going to sort my devices. The devices is the list of devices that I came up with. I'm sorting them. And how am I sorting them? Well, this is something that is a little bit interesting, but I'm using this item getter functionality and saying, okay, the key for doing sorting is going to be by vendor, then by OS, then by version. And for my tabulate functionality, the headers are going to be the keys of the dictionary. So let's run this and see what happens. Here's my output. I'm going to go back to the top. This is my list. This should look familiar. We just did device. Every one of these is a new device. I'm going through and printing out these devices. Notice everything is random. If I were to run this again, the data would be random and different from what it is. Here's what pretty print would look like. So pretty print before looked like this only, but now pretty print has the square brackets indicating that this is a list, and this is my list of devices. And lastly, here's my nice tabular format. Notice how it sorted it based on vendor, OS, and version. So vendor, Arista, vendor OS. If my vendor is Cisco, then it sorted it via OS. And then lastly, within this iOS XR, you notice it sorted it by version. So first by vendor, then by OS, then by version. And that's how it came out. So that was lesson number 2. We did another for loop, but just a numerical for loop. We learned about lists. We learned about some randomness stuff that I used to generate it. We appended to the list. We saw the pretty print, and then we used tabulate. And not only did we use tabulate, but we threw in sorted to sort the data, and that's how we ended up with this interesting and fine-looking table. That's lesson 2. So continuing on, lesson 3 is about functions, and basically all that we did was we took our code that created a list of devices and we put it into a function. How do you define a function? You use the def keyword, you give it the name of the function, you provide parameters. You can optionally provide these things which are default values, so if somebody omits that parameter, then the default value will take place. The function is going to be indented. You can indent it any amount that you want, of course, but it has to be consistent. This code in here, we're not going to need to look at because it's the same code as what we did before. We're going to take our created devices list, append the device, and at the very end, we're going to return created devices. Now look at this indentation. You got to remember to do your indentations correctly and appropriately. So that's why our return needed to be there. And so that is what we do. Now, one thing to point out, I guess, is that we expanded what we're doing not only to have devices, but also to have subnets. So we're allowing you to pass in both number of devices and number of subnets. So we have a for loop within a for loop. So we have nested for loops here. And at the end, all we do is we call our function. Now I am calling them using the keyword. I could optionally have removed this keyword, but notice subnets first, devices second. If I look up here, devices first, subnet second. If I wanted to call this with just the 5 and the 4, I would need to make sure I put the number of devices first and the number of subnets second. That's what we call when we pass the parameters positionally. So that is calling a function and passing in parameters. We would get back our list of devices, and at the end with our list of devices, we do a tabulate. We're not doing the sorting this time. It's pretty simple. So let's run it and see what happens. That's handy. It kind of fits right into this screen here. So we called in create devices and we got our devices back, and then we printed it and we used tabulate to print it. So we printed a new line and then we did this table, and it created this table which has name, vendor, OS, version, and IP. And these are the things that we created. Now we created them randomly. If I was to run this again, remember this R6UB, let's see what happens if I run it again. Notice this value is different. It was R6UB, probably doesn't even exist in this next one. So yeah, so that shows that our randomness is working and our function is working. So that's what we learned about functions in lesson 3. Okay, so let's talk about lesson 3 again. I just did lesson 3, but notice lesson 3 is named modules, and I realized I did a different week on this, but I'm talking about functions first, then modules and packages. That's what I'm referring to in here. So modules. Now you look at this code and you say, wow, this should be really short. There's hardly anything in here. Well, the reason there's hardly anything in here is the code is essentially identical to the code that we had here in functions, this code down here at the bottom that you see, but the difference is that my actual code that does stuff is going to be someplace different. And so that is where we get to when we talk about modules and packages. So all a Python module is a Python file with Python code in it that you can then import in order to make use of it. So in my situation here, I'm saying from util, you can see that over here, that's util, .create utils, and if I go down here, I can see, well, there's create utils, import create devices. Now, I can double click here, and that will take me to this file, which has a lot of stuff in it these days because I added things to it. But another thing I can do with PyCharm, as you recall, is I can do Control B, and that takes me to actually the function that I'm interested in. So this is my create devices function. Now we're not going to go into a lot of detail of all the things that I added here. If you recall, I did things like creating network. I did a little bit more intelligent job when I create device of generating a random IP address. So there's a lot of extra stuff in here, but hey, it's hidden from us. Look at this. All I need to do is call create devices and it will do what I need. And then I just import it. And the idea is that this is useful if somebody else is doing it or if I want to share it with other parts of my code or other people's code. So let's give this a shot running it and see what happens. Okay, so here we see the output. I have a nice list of devices with this randomly generated device name, operating system, version. I'm not sorting it in any way, so things are kind of mixed up in here, but you can see they're actually in the order that I created them, and I created them in a numerical order. So 1.1, 1.2, 1.3, 1.4, 2.1, 2.2, 2.3, etc. And here you can see that I passed in number of subnets is 5. That's why that number there goes from 1 to 5. And the number of devices is 4. And that's why this number goes 1, 2, 3, 4, 1, 2, 3, 4. So that's how we do a Python module. And if it's within a folder, then it actually becomes a package. You can see that in the little pop-up when I do the mouse over. And that is Python modules and packages. Okay, we're in lesson 4, strings, which is where I introduce you to a number of string functions, things that you'll want to do with strings. There's a lot of stuff in here. As I scroll down, you can see there's 127 lines in this file. And so I'm not going to go through every single line in great amount of detail, but I want to point out what you need to understand. For example, the first one would be split. That's where you take a string and you split it into a list based on the character that you provide. So there's going to be split that we're using. Another function that we're going to be using is called strip. That's what gets rid of blank space at the beginning and the ending of a string. Another thing we looked at was replace. So here we're replacing a blank with nothing. So we're basically removing blanks from the thing that we're looking at. Here we are doing the same thing, but we're replacing a comma with a colon for purposes of just transforming whatever the data is to have a colon instead of a comma. In this situation, we're going to have a loop, not a yoop, but a loop, and we're going to be doing a split of the line based on comma, and then for every single one, we are going to be doing a strip, and that will give us maybe better data that we're trying to look at here. And we'll look at the output in just a minute. Now here, guess what? I introduced you to a list comprehension. Never fear, I talk about list comprehensions down here in greater detail. So you can see I have list comprehensions under intermediate. We're not going through that at this point in time, but basically be advised and be aware that this is taking the split is creating a list, and we're going through the list, and for every item in the list, we're doing a strip. So we're doing exactly the same thing that we've done in this for loop, but we're doing it in a single line. Other things that you will be aware of in your traversal through strings and all the functions that are available in strings is being able to ignore the case. And so you can do things like dot lower. So one There isn't a comparison that says compare but ignore the case in Python, but you can do lower or upper to both sides of your equality comparison and figure out if they are actually equal, ignoring the case. You can do things like find with a string, so you can say what you were expecting to find, and then you can do a find on the actual string. So here's my string, there's what I'm hoping to find, and this is what we will end up with. You can also separate, in this example, we're separating a version string into individual components, and then I'm printing out every component one at a time. Now here's some screen scraping stuff where I'm taking output from a device and I'm attempting to do some level of screen scraping. Now I'm not doing this very intelligently, so don't go telling anybody that hey, this is the way Chuck did it, it's the best way to do it. It's not really the best way to do it. I'm just demonstrating what you can do. What I can do, first of all, this large thing with three quotes here is a multi-line string. So at the end of every one of these lines, there's a new line. I'm going to be doing a split line. So I'm going to change from one string into multiple strings where every single line is a string. And then I'm going to iterate through all of the lines. And I'm using this enumerate function. Remember, enumerate is going to give us not only the item, which is stats line, but also the index that it was from. So the first iteration through, the index will be 0. The second time it will be 1. For that line, I try to find gigabit Ethernet. That's what I'm doing here. I'm looking for gigabit Ethernet. And here's the really hokey part. If I find it, I say, oh, well, give me the thing that's 5 lines beyond that. So basically, I'm saying if I find gigabit Ethernet 1, I'm trusting that 1, 2, 3, 4, 5, the 5th line, will be the total. That may or may not be a good idea, probably not, but I'm saying that it's the totals line, and then I am going to be splitting that, and then I'm going to take the values that are not the first one, and those are going to become my actual total values up there. And here I'm looking at, and then I just print it out. Here I'm doing some level of parsing of an ARP output. I'm doing split lines again. I'm doing some more stripping with the line. This is called slicing, so I want you to remember that. I'm taking a specific portion of this particular line and I am doing something intelligent with it, allegedly. I'm basically building an ARP table with the IP address and the hardware address, and then I'm going to print that out. So let's look at what the output of this looks like. L04 strings. All right, so let's going at the beginning. Here we're using split. So remember, we're taking a line and we're creating a list using split. Here I am removing beginning and ending spaces, but not intermediate ones, using strip. Here I'm removing the blank instances, so I end up with something that looks like more like what I wanted to, where I'm using replace to get rid of the blank lines. Here I'm actually using colons to separate the data rather than creating a single string, so that I have colons in case you wanted to do that. Here I'm using a loop, and I don't seem to be able to say loop very well. I'm stripping the data for each one, and here I'm using the list comprehension to get the same data. I did my lower here. I found my substring. I separated this version string into its components, so we were talking about doing that. Here's my interface counters with the hokey way that I found them. You can see that I ended up getting the totals out of that. And then the ARP table, remember I said that I was using slice to get a slice of the string, and I was trusting that it was at this location starting at 10 and going up to but not including 25. So just so you know, this is a little bit of screen scraping. It's fraught with peril. If somebody changes and adds a space or removes a space or something, my code will break in this situation. But it shows what can be done with string functions, and that is strings. Okay, let's talk about lesson 5, which is printing. So you can see I'm importing a lot of different stuff here. The very first thing that I do is I create devices, and hey, look, just as an aside, I'm calling create devices with this parameter 25, which is a positional parameter. If I go in here and to see what it is, then that's going to be my number of devices. So my number of subnets will only be 1. So I'm creating my devices. I'm going to just print that list of devices out here. So that will be quite ugly. I'm going to do a pretty print. We've looked at that also. That will look better. I'm going to do a for loop where I'm going through here, and as I'm printing it out, I'm adding a new field to my device dictionary called last heard, and I'm sleeping a little bit of time between each one so that I'll have a different last heard time. Here I'm using tabulate. We've seen this before. Tabulate, sorted, my keys, etc. Here I'm doing my own table where I print out name vendor :OS so that it looks like it has the vendor on one side, right justified, and the OS on the other side, left justified. That should look kind of nice. Now we're going to do the same thing, but we're sorting it by last heard. So that should give us last heard in ascending or descending order. I can't remember. Reverse equals true. We'll look at it and we'll figure that out. Here we're going to be printing multiple things on the same line. So we're pretending like we're going through all of these devices and testing them, and then we're sleeping, and then we're printing done, and we should be able to see that. The last thing I do here, I'm not sure why I added this, but we're doing a port scan, and so we're calling the port scan and asking us to input an IP address, and then we print it out. There's not really a whole lot of printing stuff in here, but that's what we do. So printing, as you've pretty much seen it before, let's run it and see what happens. Here we can see this is a little bit at a time, printing these out one at a time with a little bit of a delay. So it's doing kind of what we were asking it to do, just going back up to the top. Remember the very first print statement, you can see it goes on quite a while to the right here. So I didn't do anything fancy with it. That's what happens. It just prints, it's a list of dictionaries. Here's pretty print, which does a much better job and is clearly a little bit human readable. So that's a good improvement of printing my 25 devices. Now I'm just looping through and printing each device. Once again, I'm just doing a print of the device, so it goes out to the right pretty far, but I'm using that loop. Here's my tabulate, printing out of everything. So I'm printing this information out via tabulate, and then I think I do tabulate and I sort it in this order. Remember, I was doing this sort, so now I'm getting it sorted. Was I sorting by last heard, I think. So this value here actually matches the IP address because I generated them at the same time. Oh no, this one here is sorted by last heard in reverse order. Okay, so this is my reverse order one. All right, fair enough. This is where there was that pause. Remember, I'm doing the print, and my print statement, if I want to reiterate this just a little bit, I'm printing things out, and I add end equals quote quote in order to tell Python don't finish the line yet, and then at the very end it will print out done, and that's what happens here. It waited some amount of time, it did this sleep, and then it printed done. And now it's asking me for an IP address to scan. This isn't a whole lot of information. 192.168.254.14 I think is one. So it's going to go out and it's going to actually do this port scan, and then all it does is print it out using pretty print. So pretty print looks actually pretty good. Hey, this is exactly what I do in Quokka. So if this looks familiar, if you have done Quokka, then you've seen something like this. And then all I need to do here is hit enter and it will finish. So that's a lot of different examples of printing. By the way, just so you know, I do favor fprint over doing .format or other mechanisms simply because it's easier it's easier to write, and it's a lot easier to read and to do the formatting. So that's why I'm focusing on that. Good. So hopefully you now have a refresher on printing in Python. Okay, so let's review lesson 6, comparisons. Once again, there's a lot of code in here. There's a lot of stuff going on, so I'm not going to go into great amounts of detail, but I'm just going to kind of skim over it and you can review it in your own mind. The first thing that we do is we create devices and we print them. Then we go through all the devices and we decide that, okay, we don't like Cisco, so we're going to print out all the devices as long as their vendor name .lower is not going to be equal to Cisco, and we print those out. So we print out all non-Cisco devices. Now the next thing that we're going to do is we're going to go through all of the devices that we have, and we're going to see if there's any match, because remember, when we do create devices, we're randomly generating device names. There's a chance that device names might end up being the same, and if that's true, then we print out that we found a match. So let's go ahead and run this and let's see what we get as a result. So we'll just look at the first stuff that we're looking at here. This is the very first list of all of the devices. You can see that there's Cisco devices as well as Juniper and Arista. Now here's the version that I've eradicated all of the Cisco devices. So you see in this list, there's no Cisco devices. Now here's my comparison, and I found 3 this time. I just ran it a second ago. I found 2, and of course they were different. So I'm doing this comparison of device names. That's this equal sign right here, device A and device B. Now this is a little bit interesting how I iterate through devices twice simultaneously, starting device A from the beginning and going to the end. And then for every set of comparisons, I'm doing device B starting at devices A, wherever devices A is, +1. So I'm going through it in that manner. And if I find a match, then I print it out. So there is my comparison that is now complete. And I found 3 different of these. So let's continue on with the next thing that we're looking at. What I'm going to do now is I'm going to create the standard versions by just going through my devices and arbitrarily choosing the first version of a particular OS that I find, and I'm going to say that is my standard version. Then I'm going to go through and look down here. I'm going to see, don't worry about that for a second, I'm going to look to see if the current device's version is not equal to the standard version. And if it's not equal to the standard version, then I print out, there's a non-compliant device. If I go back here, then we can look at a list of, these are the standard versions that I have chosen. And then from there, I'm going to end up finding a bunch of devices that don't match. So just to look at this one, Arista EOS, the standard version is 4.23.2f. So my failing ones should all be different than that. And sure enough, let me get it so that it's there. Sure enough, these are the failing ones. And I've done the IP address. So I do that for all of these. So the next part of this lesson deals with assignment, copy, and deep copy. Now these 3 things are different in Python and you need to understand them. This is assignment. The equal sign that you see in this situation is just assignment, and this just says have devices 2 point at whatever data is pointed at by devices. That is an assignment. The second thing is copy, and copy really is a shallow copy. It just copies the first level of a nested data structure, and so that is what you end up with here. You have a new copy, at least for the first level, but deeper levels of nested data are still the same. Deep copy copies everything, not only the top level of the data structure, but also all of them. And so these are very important. In the context of this, we then do comparisons to see if they're equal, and we point out that it's very nice and handy that in Python, you can do a comparison of two data structures just by using the equals sign, and that will recursively compare every level of nesting of every piece of data in those two data structures, and it will tell you if they are indeed the same or not. And that's why this is part of comparison. And so copy and deep copy are important here. If we were to look at the output of the data, here's where we're showing that assignment and modify. The moral that we found out was that assignment is not the same as copy. The moral is copy only does a shallow copy, and so if you ended up doing what I did, then I ended up changing the original version, which you may not have wanted to do. And deep copy, of course, copies everything and allows you to do with your copy whatever you like. So you just want to make sure that you know what you're doing there. Now, the last thing that I think we do in this particular lesson is we are dealing with a new set of devices, and we are arbitrarily setting SLA availability, and we're assigning SLA availability randomly for the devices that we're creating. So we're adding a new field or a new item in here called availability for a device and response time, and we're arbitrarily giving it some type of random number in between for response time 0.5 and 1.1, and for availability this value. And then what we're doing is we're just doing numerical comparisons with greater than or less than. And then in our output we can see that we will eventually do this comparison, and let's see, here's our availability and response time, and here we're doing the comparison. The last thing that we're going to do is comparing classes, and this is getting to something that's a little bit more advanced than just our more basic. But here we're creating a class, and our class is going to define the equality operation. And what we're going to do is we're going to examine the two classes, the one that is ourself and the other one, and we're going to check to see, in this situation, we're just comparing to see if the name and the IP address are the same. And we're going to return this truth value. And that's what we end up doing down here. So, comparison, that's what it's all about. We are talking about simple comparison of things where we just do strings, as well as all the way down to having a class where we defined our own equivalency operation. So hopefully that makes sense for you, and you have a general idea of how to do comparisons in Python. Okay, so let's talk about lesson 7, which was on nested data. What is nested data? Well, it's just basically having a data structure like this, but inside the data structure you have another data structure. Here I've got a dictionary of devices, and within devices I have a key called interfaces, and then I have a list. I have nothing in the list right now, so it's just empty. I print it out, and then I go through and I create a bunch of arbitrary interfaces. I add them to this thing I'm calling interfaces, and then I say, okay, device sub interfaces, that's this thing right here. I want it to be equal to this interfaces thing that I've got. And now I can print that out and show that the device has all of these interfaces. So that is a dictionary with one of the items in the dictionary itself being a list. Now we go to something more complicated, or more interesting anyway, and I've created this function called create network. If I was to go down into create network, I won't go into the details of this, but I'm going to create subnets, and I'm going to create devices within the subnets and interfaces for each of the devices. And so what I do after I have done this create network is I do a pretty print, and I print it out, and that shows you the very interesting level of nesting that we end up with in that particular situation. Then I just print out a little bit of data with respect to that. Then I go through and I print it out again. So I'm going through the subnets, the networks of subnets, And then for every subnet, I'm going into my devices and I print out various information about the devices. And the last thing that I do here is I revisit the idea of assignment versus copy versus deep copy with my super nested network. So let's run this and see what happens. Nested data, run nested data. And let's go to the very top. You can see that's looking like very nested data, so that's good. So here's our device with no interfaces, but it's empty. Here's my device, which is a dictionary with interfaces, which is a list of interfaces. So that's good. Here are my interfaces, a device with interfaces just using pretty print. So I printed it in my own way there. Here I'm using pretty print and it comes out in its own manner, but you can see nested data. Now remember, I did create network. I go through device creation, and it's really network creation because look at this. I have a dictionary with the first item is a dictionary, and then within that I have a dictionary, then I have a list, and the list has interface within each interface. Within the list of interfaces, I have all of these individual interfaces, and you can see this is very nicely nested data. Looks kind of cool. This is what your network representation would be. I can get some information about it. My number of subnets happened to be 4. I gave myself a list. I had it print the list of subnets, which looked like this, but I then did some removal of the extraneous information, and I ended up with my list of subnets looking a little bit better. That was just using that join function that we had. And then lastly, here's how I printed out in my own formatted manner. So I just went through and did it in my own way. I didn't do the interfaces, of course. That is a simplification. And then we did this assignment versus copy versus deep copy, and saw that when I modified something, these two values were the same. But when I had my own copy and I modified something deep down in the nesting, then the two did indeed turn out to be not the same. And that's as it should be. So that's nested data. Some really nice looking nested data there. Hopefully you have a better idea of how to deal with nested data in Python. So let's review lesson 8, which I titled enums, constants, etc. The basic idea of this lesson is this. In your code, it's a bad idea to use things like string literals all over the place, because if it's the same item and you have to replicate it in multiple places, then you're opening the door for typos, misunderstandings, etc. It's much better to define the thing beforehand. So I took a small example, which is just the name of the vendor, and I went through an example where you set a constant. So in this situation, I would say Cisco equals this string, and then I can use it throughout, and I have code commented out here that I'm not going to go through that does that. I have an example where you can define a class called vendor, and then when you reference it, you can say vendor.cisco. That kind of helps, and it makes the namespace a little bit smaller. You could end up with name collisions here if you're just doing that, but this becomes a little bit safer. So vendor.cisco in that situation. You can also define a class which is an enum, and in that situation you can define these as being actual values like numerical instead of having them be strings. Now this may or may not be a good idea. For me, I don't really like this idea that much, because you end up if you're just looking at actual data with a debugger or something, it's less clear. If you see like the value 1, you have to reference and say, okay, what is that actual value? The one that I would probably prefer is using an enum class where the actual data is the same as the thing that you're talking about. And then you can use name or value. Either one is going to be okay. And that's what this code does. It actually ends up using, as you can see, vendor.cisco.value. It's a nice way to do it if you're using enums. Alternatively, you can do the other method of just having a class, and that is perfectly okay as well. But the general idea is not to end up with string literals throughout. Now, obviously, I've got lots of string literals here. That's just because it's random values that I have and not really that important. Okay, so let's see what this looks like when we run it. It's not going to be terribly interesting. Here's a list of all the things and here's a table of all the things. So it actually looks perfectly okay. If you had printed this out using this third version where you have an enum, but the value is actually a number, that would be this one right here, then what gets printed out can be a little bit misleading because it may print out the number if it's printing out the value rather than just the name. So that's why I kind of prefer this one. Anyway, it is always a good idea to see if you can avoid using string literals in your code and instead have constants of some type, whether they're just a constant or an enum or whatever you might choose. So let's look at lesson number 9, which was a comparison of lists versus dictionaries. People ask the question, why would I use a dictionary rather than a list? The main reason is if you need to find something quickly, then you want to use a dictionary, and you can find it using the key in the dictionary. Otherwise, you would use a list. And in order to demonstrate this, I showed a simple example where I created a set of devices with 254 times 254 devices, 254 subnets, as you can see there. And for every device, I went through and I created in this list, for every device in this list, I went through and created a dictionary entry that pointed at that, with the key being the IP address. And so that allowed me to have somebody enter in an IP address, and then I would find it using a for loop with my list, and then I would find it just immediately by using the key in my dictionary, and then I print how long that it takes. I'm going to do this. I just print out this list of devices just so you can see it. I'm going to actually comment these out before we run it because it will run much faster. And I was running it a second ago, so I'm going to stop the previous running. I'm going to start one anew and enter the IP address defined. Now the IP address is going to be 10.0.something.something. And to show the very first one, 10.0.1.1, that's going to be the fastest one for the list. And you can see that the dictionary search was 3 times faster than the list. If I was to go at the other end, 10.0.254.254, the amount of time that it will take with the list is actually 3,000 times slower. And if I was to do something somewhere in the middle, 10.0.128.128, then you'd see that it's like 1,900 times faster with the dictionary. So you can see dictionary actually gets you there a lot faster. That's why we use a dictionary. And so hopefully this lesson has demonstrated why that is the case. One last thing I'll point out here, in terms of the data, I created the data once right here. This is my list of devices, and remember, all I did here was I pointed my device's dictionary item at that already existing device, because everything is an object in Python, and I'm just saying take this device's dictionary entry at key device IP and point it at device. So I only have one data structure in memory that represents all the devices. Okay, so hopefully that made sense. Hopefully what really made sense is this comparison of lists versus dictionaries. You definitely want to use dictionaries if you're going to need to get at stuff quickly, and especially also if the amount of data in your list is quite large. Okay, so we've just done a review of these basics in Module 1, from dictionaries to lists to for loops to functions to strings, split and strip, and finding and replacing. We've talked about printing using f strings. We've talked about data and doing comparisons and doing assignment versus copy versus deep copy. We've had very nested data. We've looked at using some type of enum or constant rather than string literals. And we've compared lists and dictionaries. Hopefully these have made sense to you. If any of it did not make sense or you want more, then I would recommend going into that particular lesson where I spend a good 30 to 45 minutes talking about that particular topic. So hopefully this has been useful and has helped to solidify aspects of Python that maybe you learned but haven't really committed to memory forever, and this will help that to happen. Thanks for listening.